Hello friends, let us see how to solve nonlinear programming problem using Kuhn condition. Nonlinear programming problem can be solved using two ways, either using Lagrangian condition or Kuhn condition. Lagrangian condition is used when the constraints have equality symbol. Kuhn condition is used when the constraints have non-equality symbol. Now let us see an example in Kuhn condition. So this is the problem. Maximization of z is equal to 7x1 square minus 6x1 plus 5x2 square. Subject to x1 plus 2x2 is less than or equal to 10 and x1 minus 3x2 is less than or equal to 9, where x1 and x2 is greater than or equal to 0. To solve Kuhn condition, we have four constraints, that is four conditions we have. The first condition is lambda I is greater than or equal to 0. Lambda is nothing but the number of constraints we have, that is 1 and 2. We have two constraints, so lambda 1 comma lambda 2 is greater than or equal to 0. The second condition is that L is equal to f of x minus lambda I into g of x. How many ever constraints we have to multiply the constraints with lambda. So we have two constraints, so L is equal to f of x is the maximization, that is the main condition. So 7x1 square minus 6x1 plus 5x2 square minus lambda 1 of x1 plus 2x2 minus 10 minus lambda 2 into x1 minus 3x2 minus 9. Now we have to partially differentiate L with respect to x1, x2, lambda 1 and lambda 2. So dou L by dou x1 is equal to 14x1 minus 6 minus lambda 1 minus x2 lambda 2 is equal to 0. You have to partially differentiate and then equate it to 0. Then dou L by dou x2 is equal to 10x2 minus 2 lambda 1 plus 3 lambda 2 is equal to 0. Dou L by dou lambda 1 is equal to minus of x1 plus 2x2 minus 10 equal to 0. Dou L by dou lambda 2 is equal to minus of x1 minus 3x2 minus 9 equal to 0. We take these as equations. Equation number 1, 2, 3 and 4. Now the third condition is that lambda I into gi of x equal to 0. So lambda 1 into x1 plus 2x2 minus 10 equal to 0 and lambda 2 into x1 minus 3x2 minus 9 equal to 0. Fourth condition, gi of x is less than or equal to 0. So x1 plus 2x2 minus 10 is less than or equal to 0. We take this as equation number 5. Then x1 minus 3x2 minus 9 is less than or equal to 0, and we take this as the sixth equation. Now in order to find x1, x2, lambda 1 and lambda 2, we have to take into consider four cases where we have to substitute the possible values for lambda 1 and lambda 2. So taking case 1, lambda 1 and lambda 2 is equal to 0. So we substitute this in equation 1. We get 14x1 minus 6 equal to 0. So 14x1 is equal to 6 and x1 is equal to 6 by 14. Therefore x1 is equal to 3 by 7. Then taking equation number 2 and substituting lambda 1 and lambda 2 is equal to 0, we get 10x2 is equal to 0. Therefore x2 is also equal to 0. Since x1 and x2 values are positive, we check whether if it satisfies the constraint. Either of the constraint you can check it with. So you can either substitute this in first constraint or in the second constraint. So I take the first constraint, that is x1 plus 2x2 is must be less than or equal to 10. So x1 is 3 by 7 plus 2 into x2 is 0. So 3 by 7, which will be obviously less than or equal to 10. Therefore it satisfies the constraint. So I want substituting these values into z. So z equation is 7x1 square minus 6x1 plus 5x2 square. So I substitute in that 7 into 3 by 7 the whole square minus 6 into 3 by 7 plus 5 into 0. I get 9 by 7 minus 18 by 7. So z is equal to minus 9 by 7. So this is one of the feasible solution. Case 2. We substitute lambda 1 is equal to 0 and lambda 2 is not equal to 0. Substituting this in equation 1, we get 14x1 minus lambda 2 is equal to 6. And substituting this in equation 2, we get 10x2 plus 3 lambda 2 is equal to 0. So in order to solve this, I have to multiply equation 1 with 3. So I multiply equation 1 with 3 and I get 42x1 minus 3 lambda 2 is equal to 18. So I get 42x1 plus 10x2 equal to 18. I shall solve this with the fifth equation multiplied by 5. So I will get 5x1 plus 10x2 equal to 50. And then I take this equation, that is 42x1 plus 10x2 equal to 18. On solving this, I get x1 will be minus 32 by 37 and x2 will be 201 by 37. I get x1 value as minus, so this is infeasible. Now I move on to case 3. In case 3, I substitute lambda 2 value as 0 and lambda 1 value not equal to 0. So on substituting this in equation 1, I get 14x1 minus lambda 1 is equal to 6, and the second equation becomes 10x2 minus 2 lambda 1 equal to 0. On solving this, I will get 28x1 minus 10x2 equal to 12. Now I again take the fifth equation multiplied by 5. So I will get 5x1 plus 10x2 equal to 50. On solving this, I will get x1 is equal to 62 by 33 and x2 is equal to 134 by 33. Now I have to check whether these two values abide my constraints. So I substitute in either of the constraints. I take the first constraint, that is x1 plus 2x2 equal less than or equal to 10. So 62 by 33 plus 2 into 134 by 33 gives 330 by 33, that is equal to 10. This satisfies the constraint less than or equal to. So it satisfies the constraints. So I shall find the x1, lambda 1 value, which is not equal to 0. So I have to find the value of lambda 1. So substituting these equations in first equation, I get lambda 1 is equal to 14 into 62 by 33 minus 6. So I get lambda 1 value as 670 by 33. So I've got the lambda 1 value, lambda x1 and x2. I shall substitute in z equation. So 7 into 62 by 33 the whole square minus 6 into 62 by 33 plus 5 into 134 by 33 the whole square. So the value of z is 95.78. This is again one of the feasible solution. Now we'll move on to case 4. In case 4, we take lambda 1 not equal to 0 and lambda 2 not equal to 0. So I'm going to substitute this in equation 5. We get x1 plus 2x2 equal to 10, and substituting this in equation 6 we get x1 minus 3x2 is equal to 9. On solving this, I get x2 is equal to 1 by 5 and x1 is equal to 48 by 5. So since both the values are positive, I check in whether it satisfies the constraint. So 48 by 5 plus 2 by 5 gives 50 by 5, which is equal to 10. So this satisfies the constraint. So now I find the value of lambda 1 and lambda 2, since they both are not equal to 0. So substituting this in equation 1, 48 by 5 into 14 minus 6 minus lambda 1 minus lambda 2 is equal to 0. So I get 5 lambda 1 plus 5 lambda 2 is equal to 642, which I consider as equation A. Then the second equation becomes minus 2 lambda 1 plus 3 lambda 2 is equal to minus 2. So I take this as equation B. On solving A and B, that is, I multiply A with 2. So I get 10 lambda 1 plus 10 lambda 2 is equal to 1284. I multiply B with 5. So I get minus 10 lambda 1 plus 15 lambda 2, which is equal to minus 10. So in solving this, lambda 2's value become 1274 divided by 25, and lambda 1 is 1936 by 25. So we got x1, x2, lambda 1 and lambda 2. So I substitute this in equation, the first z equation. So 7 into 48 by 5 the whole square minus 6 into 48 by 5 plus 5 into 1 by 5 the whole square. So I get z as 587.72. So this is another feasible solution. So I got 3 feasible solutions. That is, in the first case I got minus 9 by 7, and the second phase I got an infeasible solution too. So I need not consider that. In the third case we got z is equal to 95.78, and in the fourth case we got z as 587.72. Since this is a maximization problem, I consider z is equal to 587.72 as my final solution. So case 4 is final solution. So the value for x1 is 48 by 5, value for x2 is 1 by 5, value for lambda 1 is 1936 by 25, and value for lambda 2 is 1274 by 25, and finally the z value is 587.72.